Hello guys, enjoy the video as we delve into the world of electrical engineering.
Hello guys, so my name is Nicholas Lobo and I'm here with my partner Godfrey Shonai. We are going to be doing the circuit for 12-volt regulated power supply using zener diode. So we will be using our breadboard pins, and on our components we are having a transformer which is going to step down the 230 volts to 15 volts. Then we are going to have a rectifier and a 10 ohm resistor. Then we are going to have a 470 microfarad and two 1000 microfarad and two 1 kilo ohm resistors. Then our LED, which is going to indicate that our circuit is working. Then our NPN transistor. Then lastly our zener diode. So during our connection, we will start by connecting our rectifier as shown here. Then we take our 10 ohm resistor, which will connect to the positive terminal of the rectifier. Yeah. Then using our connecting wires, we create a junction on the positive terminal. Then we take our 470 microfarad and connect it to the resistor, then put it to the ground. Then we take our 1 kilo ohm resistor, connect it here. Then we take our LED as shown. We put the positive terminal here. Then we took our here, instead of 560 we've used the 1000 ohm resistor, put it here on the terminal. Then we took our 1000. According to our simulation, we have used 1000. Yes. Then we connect our BJT. Here we are having a collector terminal, base terminal. Then on the output side we are going to have an emitter. So on the input we are going to have a collector terminal. Then the base will be here. So this is our transistor. So according to our transistor, this is the emitter, this is going to be the base, and this is the collector. So connecting like this. Then we put our zener diode. So this is the P type and this is the N type. So connect it like this. So this terminal, the collector terminal here, we connect it into the positive using our connecting wires. Then in line with this, we put our 1000 microfarad which we have used in our simulation. We connect it to the ground like this. Then the emitter is going to be connected to the positive terminal of the capacitor. So this is our emitter. Connect our emitter here. We connect it to the positive terminal of the capacitor. And using our next connection wire here, we are connecting this N-type to this, like creating a short. Our base here on our base terminal, creating a space using our connecting wire. Yes. And we try to connect. So, according to our given diagram, this is our circuit. So next we are going to see if it is working or not. Now, as we have connected our circuit, now we want to know if it is working properly. For us to know that it is working properly, the LED has to light. So, turning on the switch, as you can see, the LED is working. Now, to see whether the output has been regulated on the output on the capacitor, across the capacitor, we use the multimeter to see the output that is coming out. So using the multimeter, measuring the voltage which is across the capacitor. As you can see, the output is 11.27. It is not giving 12 due to the drop which is going to be up on this BJT or NPN transistor. So to see the waveform, we are going to use the DSO to see the waveform which is going to come, which is across this capacitor. As you can see, the waveform is coming out straight, which is showing that the output is DC, and here our min is approximately 11.6, showing us that the output has been regulated. So showing us that the zener diode has regulated the 12 volt. Thank you.
We have our circuit and we have our outcome, and we have this. We have seen that we have obtained our DC, which is regulated, and it's 12 volts or 11.8, okay, in the range. Now what's actually happening here is we are having our transformer like we see on our diagram here, which is a 0 to 15 volts transformer. Okay, so it's stepping down our 230 AC to 15 volts, yeah. And then afterwards we are having our rectifier, our bridge rectifier, and this one is fixed. We are not going to use individual diodes here. And then we have connected it like this, and then we got our output, which is rectified, and it is now a pulsating DC. Okay, now we are having a 10 ohms resistor and it also limits our current to a certain extent. Okay, now all these capacitors here will be smoothing our voltage. And then here we are connecting our 1 kilo ohm resistor and our LED. In this case we used a red LED. Okay, and now whenever we are connecting an LED, we have to connect it in series with a protecting resistor. This one it will prevent it from blowing out. Okay, and then in another branch we have a 560 ohm resistor and a 100 microfarad capacitor. Okay, and then now we have after the drop in the 560 ohm resistor, we have a shunt which is connecting the branch with a 100 microfarad capacitor and 560 ohm resistor onto the base terminal of our transistor, and here we are connecting the collector terminal of our transistor to the main positive line in our circuit. And then we have our zener diode, which is we can say the main regulating component here. And then the transistor, we have connected the transistor because we will be obtaining very low current, and this transistor will help us to get a suitable current which is appropriate. Yeah, we can say suitable for this 12 volts regulated power supply using a zener diode. And then here we have our last capacitor which further smoothens, and also we have collected our output to see our waveform and the value from a multimeter from this capacitor. And generally this is our 12 volt regulated power supply circuit using the zener diode. With this